Okay, students, good morning, good afternoon, good night, whenever you're watching this video, wherever you're at, welcome to the second lesson of Unit 3. All right, and this is actually a big punchline of the unit. Today's a very important day. In fact, it's so important we're basically practicing the same stuff again tomorrow, really emphasizing it, making sure we knock it out of the park, because this stuff we're using this today, big punchline of Unit 3, and in fact, we use this stuff throughout the school year. Especially like alternate interior angles, that's probably the most important one. Corresponding angles, postulate's pretty important. Even consecutive interior angles. I love alternate exterior angles, but unfortunately that's probably the least important one out of all the important stuff we're talking about. But nonetheless, all right, this stuff is in the iBook. So let's go ahead and pull up the iBook. All right, so we got it right there. All right, let's get to where we need to be. So let's see, pull a notability along. Okay, so investigation 1, let's tap it, open it. Okay, so this is going to take us to GeoGebra. All right, and this is stuff with corresponding angles. All right, now look, I can interact with this stuff as it loads. All right, so what do we think is true about corresponding angles? First off, notice that they're angles that are in the same relative position. All right, in this top we have this group of 4, in the bottom we have a group of 4 angles. They're both the top right. Now actually let's do some sliding. All right, I can slide the line, I can do that, I can do this. Ooh, that's my favorite one. Tell me when to stop. I'll wait till I can hear a student in my head tell me to stop. All right, someone told me to stop right there. Now, corresponding angles are always, boom, they're always going to be congruent. All right, interesting stuff. All right, in fact, while we're here, so I don't have to keep, oh, see, looks, shows that that's congruent as well. That's congruent. Well, obviously that should be congruent because that was congruent. These are vertical angles. All right, going back and forth. Same with this, vertical angles. All right, so big punchline, corresponding angles are congruent. All right, so if 2 parallel lines are cut by a transversal, then corresponding angles are congruent no matter what. Big punchline of the day. All right, and then this is a typical example we'll see. Let me make that just a tad smaller. Oops, I'm struggling, I'm sorry. There we go. All right, if angle 3 is 52 degrees, then what's angle 7? Well, that would be 52 degrees. All right, and that's just one example of corresponding angles. They're in the same relative position. All right, in this case, in this top group of 4, so let me say like this. We have this top group of 4, angle 3 is the bottom left. We have this bottom group of 4, angle 7 is the bottom left. That's why they're the same relative position. Now you can write this, measure of angle 7 equals 52 degrees. And would this be true if lines were not parallel? The answer is no. All right, that's a huge punchline. If 2 parallel lines, notice I even highlight or underlined and bolded parallel. All right, and in case you forgot from yesterday, how do we know that these lines are parallel? It's these double arrows right here. All right, that's the big punchline. So that's corresponding angles. Corresponding angles are congruent. All right. Now we got consecutive interior angles. So what investigation are we going to click? Investigation number 2. So consecutive interior angles. All right. What do we got? Okay. So these are consecutive interior angles because at this transversal, we can say that they're on the same side as the transversal. Notice how they're both on the right side. Furthermore, the parallel lines, they're on the inside. So consecutive, same side, interior, inside. Consecutive interior angles. And again, we can play around with this, make that go back and forth. Ooh, that one makes me a little seasick. Or that. I like that one right there. Now, what's going to be the punchline? What's so great about consecutive interior angles? Why do we care about them? Well, this is the reason right here. This pink angle and this gray angle, Well, that just shows that they form a linear pair. So if I slide it all the way up here, well, this pink basically going up to the corresponding angle stuff. So because of corresponding angles, we know that they can technically form a linear pair, which means that they're supplementary. And then that, in fact, is the punchline there. Is consecutive interior angles are supplementary. All right? And that's even the consecutive interior angle supplementary theorem, CIA supplementary theorem. If two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. You remember I told you guys supplementary was a big punchline of the school year? I wasn't lying. Same with linear pair, even vertical angles. We're going to be talking about that stuff a lot in this unit. All right, so in this example right here, measure of angle 3 equals 120 degrees. So I purposely picked this angle measure because look, that angle appears acute, but a little fun fact, us math teachers just copy and paste stuff from the internet and then make up problems. It's just really for visual representation. Okay, so that's angle 3. Sometimes the pictures themselves won't entirely match up. Angle 5, well, these two angles, they're consecutive interior angles because they're on the same side. They're both on the left side of the transversal, and they're both on the inside of the parallel lines. So that must mean that they're supplementary, so that's 60 degrees. All right. And would this still be true if lines were not parallel? Nah, bro. Only works if they're parallel. Okay? So that's consecutive interior angles. And again, we use that stuff throughout the whole year. And in fact, we know about quadrilaterals such as parallelograms because of CIA theorem. All right? Next, my personal favorite, but yes, I did say it's the least important, but alternate exterior angles are just really cool. All right? So we're going to click Investigation 3, Open. So we'll awkwardly wait as this tries to open. If it doesn't, oh gosh, please work. Please work, GeoGebra. Well, instead of just awkwardly wait, I'll just talk about it myself. All right. So alternate exterior angles are 7 and 2, or even 1 and 8. All right. Let's focus on 1 and 8, just because. What appears to be true about them? Well, when we emphasize them, they look congruent. And in fact, some stuff we're going to talk about in great detail. Well, 5 and 8 are congruent because these are vertical angles. Well, 5 and 1 are congruent because they're corresponding angles. So 1 and 8 are corresponding or congruent as well. So exterior angles are congruent. And we have the alternate exterior angles congruence theorem. All right. So similarly, if angle 2 is 120 degrees, what must be the measure of angle 7? 120 degrees. And you might say, well, that's clearly an acute angle. That's not 120 degrees. You want to see something that's cool? I always like talking about this. All right. I'm going to draw a right angle. I'm going to perfectly draw a right angle. No complaining. You can't say, Mr. Oswald, that's not a right angle. Look at that right angle I just drew. Does that look like a right angle? You're probably shaking your head saying no. What is this teacher talking about? He's lost his mind. Well, watch this. I didn't finish my picture yet. You got to let me finish. If I do this, the angle is going to appear to become right before your eyes. All right? So if you're hating on it, saying, no, that's not a right angle, a little messed up right there. But now with some perspective, I messed up just a little bit, but just deal with it. Now it looks like a right angle because it's part of a cube. All right, so there's always some perspective in this class. So maybe you're just looking at this picture from a funky angle, and it in fact is 120 degrees. But anyways, would the alternate exterior angles congruence theorem be true if lines were not parallel? And again, the answer is no. Frowny face. All right. And then the last one, let's not give up on good old GeoGebra. Let's see if this investigation works. Let's look at alternate interior angles. This one appears to work. All right, so here's a pair of alternate interior angles. Again, alternate because they're on opposite sides of the transversal. Interior because they're on the inside of the parallel lines. And again, we can go bloop, 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 bloop. I like that picture right there. Slide me. Alternate interior angles are always congruent. Even that, oops. Can't show the second pair, I guess. Okay, that's enough of you, GeoGebra. Let's just go back here. So again, alternate interior angles, basically for the same reasons as alternate exterior angles, they are congruent as well. And again, to emphasize things, they're alternate because like 3 and 6, notice how they're on opposite sides of the transversal, but they're on the inside of the parallel lines. And I didn't mention it before, but alternate exterior angles are on opposite sides of the transversal, but they're outside the parallel lines. So if angle 3 is 120 degrees, what's angle 6? Well, that's also 120 degrees. And would this be true if lines were not parallel? The answer is nah. Okay, stay tuned for more information.